Hi students, today we are going to observe the trigonometry. So trigonometry means we have many formulae in that, right? So to remember these formulae, it is very difficult for the students. So how to remember the trigonometric formulae easily within short period? Let us look at this. This problem is going to be solved by our great hexagon. What is hexagon? Hexagon is a six-sided figure, right? It has one, two, three, four, five, and six vertices. And if you draw the diagonals like this for this hexagon, and then you mark one at center. What is the use of this one is suspense. We will observe later. Okay. Now we generally use in trigonometry the which is the formula we are using. We are using tan theta is equal to sin theta upon cos theta, right? So with this formula we are going to set up our great hexagon. How do we set up? Setting up of great hexagon is very important. Let us look at this. How do we set up? Now we start at this point. You mark this vertex as tan and this as sine. Next, this as cos and this as cot and this as cosec and this as sec. Like this, in clockwise direction, we are going to mark. Got it? Next, what is the next step we are going to do? Now, you observe here, tan theta is equal to, tan theta is equal to, this tan theta is equal to sin theta upon cos theta, right? But that is the first step we have written. Now, if you go to the very next, after tan, we have sine, no, we are going in clockwise. So sin theta. Now, how do we do for sin theta? So what are the next two ratios for after sine? So sine theta is equal to cos theta upon cot theta. Got it? Now, if you want to go with, cos theta, what it might be? Come on, guess it. What are the next two? Cot and cosec, right? So cos theta is equal to cot theta upon cosec theta. Yes. So now what about cot theta? Cot theta is equal to cosec theta upon sec theta. Right. These are if you go in clockwise direction. Yes. Now how it should be in anti-clockwise? Come, let us look at this. So I am going. So if I go in clockwise, tan theta is equal to sine by cos. If I go clockwise, now I am going in anti-clockwise direction. Okay, like this. So anti-clockwise direction, what will be the tan theta? Come on, look at this. So tan theta is equal to sec theta upon cosec theta, right? Next, sin theta is equal to tan theta upon sec theta. Sin theta is equal to tan theta upon sec theta. Okay, you go in anti-clockwise, not in clockwise. That is very important. Next, cos theta is equal to sin theta. Cos theta is equal to, just you go in anti-clockwise, sin theta upon tan theta. Okay, like this, we are going to write all quotient identities. These are called quotient because we are writing in the quotient form, right? Or we are writing in the fraction form. So these are called quotient identities. This is one set of trigonometric formulae. Not only this, there are more. Come on, let us look at the next things. See here. So how to frame our greater hexagon? In order to frame the great hexagon, what we do? Just first we are going to draw our hexagon. Okay. After that, what we have to do? We have to draw the diagonals, right? Very good. And then we are mark one at center. This is the suspense. Okay. Next, we are going to take our great formula. What is that? Tan theta is equal to sin theta upon cos theta. So we are starting with tan theta. That is the great thing. Okay. Tan theta is the great thing or great trigonometric ratio we are considering. tan theta, and then next followed by, because here tan after sine and cos. Okay, tan after sine and cos. So tan, sine, and then cos I kept. Okay. Next, one more thing I want to say, I forgot. So here tan opposite is always cot. What you have to keep? Tan always opposite cot. And one more thing you have to remember is, on the right side always all co-ratios, all co comes. So we have cosec, right? All starts with C, right side. Okay, like this we are going to frame our hexagon, and the remaining is sec. So what we do, just by using this formula, tan, sine, and cos, you go like that. Tan opposite always cot. Cot should be always opposite to tan. Okay, and then all all co ratios, that means they starts with the CO letter, those should be on the right side, right part. Right part means, you see, this is the central part you take. This is the central part if you take. So this is right part, right? So all right parts should be cos, cot, and cosec. So all starts with C. Okay, understood? So like this, you have to frame your hexagon. Okay, after framing the hexagon, now we are going to, we observed quotient identities. Now we are going to observe the other set of formulae. What are those? Come on. So now you have to go with clockwise direction, right? These should be in clockwise because we are starting with the tan and we are going in clockwise. Okay, got it? Now let us observe what is cosec theta. You see, you observe here, you can observe cosec theta. Cosec theta is here. Cosec theta is equal to 1 upon, now this one is placed here. Okay, 1 upon sine theta. Okay, and similarly, now can you guess any other thing? So what about cos? Cosec theta is equal to 1 by sine theta. Yes. Sec theta is equal to 1 upon cos theta, right? Because these two are, oh, you see, go along diagonals. Go along diagonals. You take any one, either cos you can take, cos theta is equal to 1 upon sec theta, or sec theta is equal to 1 upon cos theta. Okay. Similarly, can you guess the other one? Yeah, cot theta is equal to, I am writing cot theta. Cot theta is equal to 1 upon tan theta, or tan theta is equal to 1 upon cot theta. Okay, like this. So sin theta, just we observed in reverse manner, reciprocal of these. Sin theta is equal to 1 upon cos theta is equal to 1 upon secant theta, and tan theta is equal to 1 upon cot theta. Okay, like this we got all reciprocal and product identities. Here, why do we call product identities? Means you take here cosec theta is equal to 1 upon sin theta. So can I write sin theta into cosec theta is equal to 1? Yes. Yes. Next, cos theta into sec theta is equal to 1. Okay. Next, tan theta into cot theta is equal to 1. Okay. So we are getting these product identities and as well as these reciprocal identities. That's why this can be called as reciprocal and product identities. Correct. So framing of hexagon is very important. Okay. Yes. Let us move to the next bit. So are those formulae are completed? No. Still we have. Be ready for that. Come, let us move to our next. So first, what do we need? In order to complete that, we need our great hexagon, right? Yeah, come on, set up hexagon. Yeah, I set up hexagon and I have drawn all diagonals, okay? And I marked the center point as 1, okay? And then with respect to tan theta is equal to sin theta upon cos theta, I am going to mark the have different vertices as sine, tan, sine, cos. Okay, and tan opposite is always cot. Very good. And then all trigonometric ratios which starts with C should lie on right side of. This is the right part. You see, which is the right part. This is our right part. Okay, this is our right part. This part is right side. So what are the right part? Cos, cot, and then what should be the other one? The other should be cosec. Yes, the other should be cosec. Next cosec theta, and only sec is left. Okay, like this we are framing our hexagon. Okay, after framing hexagon, but we should go in clockwise direction. That is very important. Okay, we are going in clockwise direction and we are observing. Okay, very good. Sorry. And center we kept one, right? Yes. Now, what you do is you observe, say you leave this triangle, you start with sine now. I am starting with a sine. Let us observe. I am taking this triangle, this arrow mark triangle. Are you observing the second arrow mark? Yeah, I am observing this triangle. This triangle can be, I can write sine square theta plus cos square theta is equal to 1. You know this already. I have Pythagorean identity, right? Sine square A plus cos square A is equal to 1. Now you leave one triangle. So you observe here. So this is 1, this is 2, this is 3, 4, 5, and 6. Okay. We have, these are the different triangles formed in the hexagon. You take first one and third one and fifth one. Like this alternately you take. You skip one triangle and you go on observe the different identities. What do we get? Okay. Now if you observe this, so with this arrow mark, the arrow mark is started at this end. That is very important. Okay. Sine theta plus sine square theta plus cos square theta is equal to 1, or sine square A plus cos square A is equal to 1. Yes. Next. Now, if you observe, so we have to leave the second triangle, right? And we have to observe the third one, right? I told alternately we are going to take. Now, you start with 1, okay? If you start with 1, 1 plus cot square theta is equal to cosec square theta. If you go like this, 1 plus cot square. If you observe in a easy way, like this is the arrow, okay? Here, this bigger one is the arrow mark, like this. You go with, okay? 1 plus cot square A is equal to cosec square A by observing this third triangle. Okay. Now, let us move to the, because we are leaving this fourth triangle, right? And we are observing the fifth triangle. Now, you observe the arrow mark like this. 1 plus tan square A is equal to sec square A. What is that? 1 plus tan square A. That is, you start with 1. Okay. 1 plus tan square A is equal to sec square A. And if you go with anti-clockwise direction, then you are getting the different ratios. Okay. You are getting the different ratios. And let us observe them. Now, come on, look at this. So these are called Pythagorean identities. If you take, if you start with cos square A is equal to, cos square A is equal to 1 minus sin square A. Okay. Next, cosec square A is equal to, cosec square A is equal to 1 plus cot square A. We already written. Suppose I start with cot square A. Cot square A is equal to cosec square A minus 1. Okay. Cot square A is equal to cosec square A minus 1. Okay. Next, in this case, tan square A is equal to sec square A minus 1. Okay. In this way, we can write all with Pythagorean identities by using this great hexagon. Is it interesting or not? Is it very interesting, right? Yeah. Okay. So not only this much, there are some more. This is not the last one. Come on, let us look at it. So what we have to do? What is our setup? Our setup is first setting up the great hexagon, right? So after fixing the hexagon, we are going to draw the diagonals and keeping center at 1, and we are taking our great formula. What is that? Tan theta is equal to sin theta upon cos theta. Depending upon that, we are going to tan, and then after sine and cos, okay, and all trigonometric ratios on right side of a hexagon should be all starts with C. That's why we are taking cos, cot, cosec, and the last left is sec. Okay. Yes. Now but these should be in clockwise direction. Okay. This is very important. This is our setup of hexagon. Very good. We got hexagon setup. Any other things? Yeah. Observe this arrow mark and guess. Come on. Any guesses? Yeah, very good. Yeah, you observe here. Sine of 90 minus theta or 90 minus x is equal to cos x, right? Now, you go on drawing along horizontal lines. Okay? If you go on drawing along horizontal lines, you are getting tan of 90 minus x is equal to cot x. Okay? Similarly, secant of 90 minus x is equal to cosecant x. Yes? So these are called co-function identities. Why? Because you are getting sine 90 minus x, right? So that is co-ratio you are getting. Okay? Cos x, tan, for tan, cot x co-ratio, for tangent, cosine. You see? Why they are called co-function means sine, cosine, cosine. Why? Cos means, so in cos, what is the actual cos? Cosine. That's why sine co-ratio is cosine. Tan co-ratio is cotangent. Okay. Next, sec co-ratio is cosecant. That is the full form. Okay. So you observe here, you are getting co-ratio. Yes. Co-ratio we are getting. Yes. So that's why these are called co-function, sorry, co-function identities. Very good. Let us move to the next sine function. Yes, in order to draw the sine function directly, we are going to set up our hexagon. Yes, I am making my hexagon very fast because we know all we are drawing diagonals and we know the great formula. Sin theta is equal to, sorry, tan theta is equal to sin theta upon cos theta. We are marking sine, cos, tan, cosec and sec. Okay, and we are going to set up our main, what do you say, hexagon. Okay, now you observe the sign here. Now sine I am taking, so sine of minus theta, sine of minus theta is equal to, what happens, minus sine theta. How to remember that? Let us observe. You start with sine. Now here sine is minus, okay, and 2 minus, okay, and cosecant also. Cosecant of minus theta is also minus. Diagonal all elements which are having the same sign. Okay, same thing they are going to give in sine function. So sine of minus theta is minus sine theta. Cosecant minus sine theta, cosecant minus theta is equal to minus cosecant. Yes, very good. Now let us observe the cos. Cos of minus theta is equal to plus cos theta, right? So cos is plus, then what about secant? No doubt secant. The diagonal element, no, this is secant. That is also plus. So secant of minus theta is equal to secant theta. Very good. And then next, look at tan. Tan of minus theta is equal to minus tan theta. Yes. Okay. Tan of minus theta is minus tan theta. And cot of minus theta is minus cot theta. Okay. Like this, we can easily write all sine functions by using this great hexagon. Okay. Is it clear? Great hexagon. Now, in this great hexagon, you observe here how to remember this sine function. Okay, you are starting with sine, right? You are starting with sine. So you start with negative, negative, positive, negative, negative, positive, negative. Like this, you can't remember, right? So simple thing is you go in diagonal way. Okay, diagonally, whatever the diagonal trigonometric functions, those should be having same sign. So sine is positive, you remember like that. So only sine you remember. Sine is negative, sorry. Sine is negative and cos is positive and tan is negative. These three you remember, then you can easily write all trigonometric functions with signs. Yes, very good. Thank you.